Welcome to this session. We're going to be focusing on this station, visual models for volume of cylinder, cones, and spheres so that students can understand this special relationship that exists between them if they have equal heights, as well as the base area is equal as well. So we're going to be discovering this and using demonstrations to help solidify that this relationship exists and to create an easy access to pulling that information out later on through this visual demonstration. Now, we're really focusing on the relationship during this time here at this station, this make and take between the cylinder and the cone. But later on, there is another video that you can have access to where you will also see the relationship for discovering the volume of a sphere. Now, again, we're focusing on these two. And so we're going to start another little video here that's going to continue on where we show what are you going to do with these two different flat patterns, or what we say nets, and how you're going to use, instead of water, which is in the actual bigger demonstration that involves all three of them, but we're going to be using simply cardstock with these flat patterns on it and rice. Very easy cleanup. So let's get started. Step one is you're going to take one of the packets that actually contains the flat pattern or net for the cylinder, and you also have the flat pattern and net for the cone. Now there is some writing on here. That's actually part of 2. Part 2 is actually when I identify this is going to be considered our slant height of the cone, and it's not going to be used in the volume when we're calculating volume. And that's what this activity is. It's going to be helping them identify the relationship between the volume of a cone to the volume of a cylinder. So step 1, cut that out. Now, in the cutting out, we want to make sure that we cut out the tabs for the base of the cylinder, and not necessarily the tabs for the top of the cylinder, because the cylinder, when it's finished, will actually need the tabs because you'll tape those on to give it some stability, but you will only need this cutout without the tabs, or with it's up to you, but I would recommend them just cutting out just the actual circle, because we want them to be able to compare the circumference or the area of this particular circle so that they can find that they are truly equal to each other. Okay? Now, the reason why we want to identify the, eventually we want to actually write that this is going to be the height. So in step 2, we're going to make some additions to our flat pattern. We want to actually identify this as the height. But the height for the cone, so this is the height we're going to be using, is different. And that is why in the cone it's really going to be the same as the altitude. So that's kind of invisible. That's what we're going to find when we lay it down and we find how the height of it. Now, what we're going to notice is that we can compare them. When we compare the heights, this one is going to be, okay, let's get this exactly right. We go to compare the heights and we put it, this is not going to be the same. And so we want to actually make that mark. So with both hands, you're going to make a little mark here and try to get that as exact as possible. And so we're going to make a small little line here so that when we're pressing down and really getting a good height here, that we can actually measure it to be the true height. When we go to do our filling with rice, this is what we're aiming for. Not the actual complete top, but we're going to be aiming for this. Now, It's going to be up to you. If you decide with your group that this needs to be then trimmed off, remember, then you can continue to cut this off, and then you can actually create two three-dimensional shapes that have equal heights. But we want to make sure that we draw attention to this. And this is where that intentionality comes in. So the more that we draw attention to the fact that they need to be the exact same height, and that the slant height is not the height that we're actually going to be using for the volume, that's a key piece. So slant height is not the same as the height or the altitude of a cone. More to come. So now that I've filled the cone up to the top, I'm going to now dump it into the cylinder, and you would want the students to be doing the same. And it's important that they fill it up to the very top. So I might need a few more pieces on within my cone to make sure that it's completely full. So I added a few more, and let's go here. Now notice, we had some spillage. That's going to happen, so you're going to be thinking about how can we actually bend this cone and actually create a better environment. The nice thing is that if it does spill, you should gather it up. So I advise sometimes either to put it on a paper plate or in another plastic bucket or bowl so that you can capture any little grains of rice that we need. Okay, we'll do that again. Now, students should be able to judge or estimate how full that is. They should be able to go on the outside and determine, is it half, less than half? Some students may say it's about a quarter of the way full. Some may say a third of the way full, but the majority of your students should not be thinking a half. Let's go with the second one after we gather these other little grains of rice. So I added a few more, and let's go here. Now notice, we had some spillage. That's going to happen, so you're going to be thinking about how can we actually bend this cone and actually create a better environment. The nice thing is that if it does spill, you should gather it up. So I advise sometimes either to put it on a paper plate or in another plastic bucket or bowl so that you can capture any little grains of rice that we need. Okay, we'll do that again. Now, students should be able to judge or estimate how full that is. They should be able to go on the outside and determine, is it half, less than half? Some students may say it's about a quarter of the way full. Some may say a third of the way full, but the majority of your students should not be thinking a half. Let's go with the second one after we gather these other little grains of rice. Here we are. More than half. How many more cones will we need to put in here in order to fill this to the top? Provide some wait time, and let's go, and let's experiment. Now I want to say that it's probably easier to grab a big spoon and pour it in instead of actually trying to pour it straight from the measuring cup or from another bowl. This isn't a very wide opening, so here we are. This is number 2. You want to be asking students, not telling them, asking them to think, estimate. How full will this cylinder be once this cone is in place? So we have our third cone, and all we need to do now is dump it in. And remember, you might get some grains of rice. That have spilled out. You'll need to add those to it. Voila. with the spillage that we'll need to pick up. Here we are, going back, just taking a few minutes. We just experienced this whole concrete demonstration where we're using the relationship between that volume of a cone. And so students should now be able to feel, really experience that relationship, that it took 3 of the cones that would fill the actual cylinder that have congruent base areas and congruent heights. So that's a big piece that will help them pull that information later. So this instructional sequence we have is concrete, semi-concrete, abstract, and many times students only experience the abstract. And what we want to do is we want to have them have some other ways to access some memory. So we've just experienced the concrete, and what you want to see here later on is that this is an instructional sequence. And so what I did is I pulled from that video that I kind of mentioned before, and I'll show you a little bit. But here are some little still shots of them. This is the students that were in my class that actually were experiencing this, and so they get to experience doing this demonstration. And that was one of my biggest regrets, is that we only had enough materials for a few students to do it. I really want everyone to be able to do it. And so I've moved now to more of the rice and the cardstock so that all students can make that discovery. You will see that it's also connected to students using the whiteboards and drawing out this relationship, being able to see where all this, where the heights and the base areas are important pieces before we even get to that formula very abstractly. So make that connection. And lastly, before we end this is that video. You can find it through Common Core. You can Google it on YouTube. If you go Google Kim Snowball and the volume of cylinders, spheres, and cones, or just Kim Snowball and finding the volume. But I've also included it on that resource link just in case. But great opportunities for students to actually build some visual supports here through demonstration. Thanks.